Hello, and welcome to another video. In today's video, we'll be going over basic differentiation and how to find the derivative of a curve. So, differentiation can be denoted, as either, um, we can denote it as f prime of x when the function of one function of x is the function we're trying to find the derivative of. So for example, if we had the function of x equals x squared, its graph would look like this, correct? Now, we have a curve here. The rate of change, there's a rate of change in the slope. The slope is not constant. So why is that? It's because it's not a linear line. In linear lines, the slope from this point to this point to this point, they're all the same slope. The m is constant. However, in curves, things like exponential functions such as x squared, x cubed, x to the power 4, x to the power 5, they're all curved. There's a curve on it, meaning the slope is not constant. So here in this case, what we do is we find the slope of a tangent. We find the slope of the tangent to the line. Now, what is a tangent? A tangent is a line that crosses, it does not, sorry, that touches the curve at one point and then never touches again. So let me draw out another function. So for example, the function of x equals negative x squared. So this would look something like this. Let's say plus 1. So this would go above the y-axis. It'll touch at 1 and then it'll go down. Now, let's say I told you to find the gradient at x equals 3. How would you do that? Now, I have to tell you where to find the gradient, right? Because at every x, there's a different gradient. So what if I told you to find the gradient when x equals 3? Now, you cannot just say, a when the formula is in this form, ax squared plus bx plus c, then a is the slope. No, this is not like a linear line, nor is b the slope. That's not how it works. Here we do something called differentiation. We find the derivative of a line. The derivative of a line can be denoted, as I said before, as f prime of x. F prime of x. Now, we can find the derivative by two ways. We can either find them by the first principle, which for many syllabi is not required, or by the shortcut, as I like to call it, the shortcut. Now, in the shortcut, both of them give you the same answer, of course. The first principle is a more advanced way that is not required in most syllabi. The shortcut is the way to go, if they don't want you to show your work or you just want to get it quickly, you just want to get the answer as soon as possible. So here we follow a set of rules. So first of all, the rule number 1 that we have to follow. The derivative of a constant when the function of x is a constant. So for example, the function of x equals 2, the derivative is always 0. So I'll explain why when I explain another rule. So rule number 2 is when the function of x equals ax the power of n, the derivative of that of that function would be anx the power of n minus 1. Here where we multiply what the value of n was to a, and then we have that as a coefficient of x, and we subtract 1 from the power. This is, of course, the result of differentiating by the first principle. I might explain it later in the video. Um, So now I'll explain why the function of a the derivative of a constant is always zero. So here, in the function of x equals 2, can't we write that as 2 times x to the power of 0? Because anything to the power of 0 equals 1, and 1 does not, um, 1 does not, that's just goes out the 2, that's not part of the same. So x to the power of 0 is always 1. And when we multiply by 1, we do not make a difference. So we could write the function of x equals 2, for example, as the function of x equals 2x to the power of 0. Now, when we use this rule, where n here is 0 and 2 is a, we can use that. So now the f prime of x equals 0 multiplied by 2 multiplied by x to the power of minus 1. Now it does not matter, we do not need x to the power of minus 1 because 0 cancels everything out. That's why the derivative of a constant is always 0. Now let's try some example problems using the shortcut to find the derivative of a line. So let's say I gave you the equation, the function, sorry, or the equation really. I can just say y equals x cubed. Let's keep it simple for now. Well, actually, 3x cubed plus 2x minus 3. So I do not really have an idea of how, I do have an idea, but I don't know how exactly. So since the 3 is positive, it's going to be going up, and it's the y-intercept is minus 3. So it'll look something like this. It does not have to be exact for us to find the derivative. Now, I told you, find gradient when x equals 3. So we have to find the derivative of this line. Now we follow the rule and we say f prime of x equals 3 times 3 is 9, and 3 minus 2, 3 minus 1 is 2, and then what was the power there? So that's 1, and then 1 times 2 is 2, and then that's x to the power of 0, which is 1, so 2 times 1 equals plus 2, and then as we know, the constant just disappears. So this is the derivative of this line. Now, how do we find the gradient? Simply by substituting the value of x into this derivative. So, gradient at x equals 3, we can substitute in there, equals 9. That doesn't make sense. Where's the pen? There you are. 9 times 3 squared plus 2. Now this is 9 times 9, which is 81, and 81 plus 2 is 3, so this is 83. So the gradient at x equals 3 is 83. Now, sometimes they might try to trick you, right? And they might say, find the point. Now I have to be careful. It says point and not just the x value. Find the point where gradient equals 38. Okay, so let's solve this. So find the point where the gradient equals 38. Now, what we do here is we plug that in to there. We plug that into the derivative function. Now, the gradient, of course, is going to be equal to the derivative. So we can replace f prime of x as 38. So here it says 38 equals 9x squared plus 2. Now we can quickly solve this. Minus 2 minus 2, 36 equals 9x squared. Divide by 9, divide by 9. X squared equals 4. And here we know that x equals positive slash negative 2. So this tells me, as a student, that there are 2 points at which the gradient is 38 and both of them, their x coordinates are 2. Now, how can we find the y? Well, if you said substituting into the derivative, that is wrong because the derivative is um, it's in charge of giving you the gradient. It has nothing to do with y. What we do is we substitute into this equation, the original equation. So 3x cubed plus 2x minus 3. Now, we just substitute this 2 into there. So y equals 3. And then let's take the positive one first. 2 squared plus 2 times 2 minus 3. Y equals 4 times 3, 12, plus 4 minus 3. Y equals 13. So our first point is 2, 13. What about our second point? Then we substitute the negative 2. So y equals 3 times negative 2 squared plus 2 times negative 2 minus 3. So of course here the negative 2 makes no difference, so it's still 12. Y equals 12. Here it does make a difference. Now it's minus 4 minus 3, which gives us 5. So our 2 points where the gradient equals 38 are 2, 13, 217, sorry, 213, and negative 2, 5. These are the 2 points. Let me highlight them. Those are our final answers. These are the 2 points at which the gradient is 38, which does make sense. So 38 is a positive number, so when we look at the curve, so this will probably be somewhere around here and here, because both of them are rising. Now let's do a couple more practice problems about this just to make sure you guys have it down. Another rule that I want to introduce, which could be helpful to you, rule number 3, which is function of x. When the function of x equals ax to the power of 1, then f prime of x would just be a. Okay. Now let's solve a bit more trickier questions, some more trickier questions. So what happens if n is a negative number? What happens if n is a fraction? Then we just follow the laws of exponents. So let's say I told you find f prime of x when the function of x equals, for example, 4 over x. Now, we do know that 4 over x, using the laws of exponents, since x is raised to the 1, we can just make this turn into 4 to the power of x minus 1. Now, here we do not have a problem. We can use the anx and to the power of n minus 1 rule here. So let's implicate that. So negative 1 times 4 is negative 4, and then x, and then the n minus 1 is negative 2. Be careful here. Minus 1 is 2. It's not 0. We're not adding 1, we're subtracting 1. Okay. So what happens if it's a fraction? So for example, let's say the function of x equals 3 and cube root of x squared. Now, we know we can rewrite this, so of course find f prime. Find f prime of x. And let me just make this a bit thinner because it's really hard to write with. Okay, so now we can write this, of course, as 3x. And now here we can use what it is raised to as the numerator and the root as the denominator. So 3 cube root of x squared can be written as 3x to the power of 2 over 3. Now we can implicate what we have said before. So the rule, so we multiply 2 over 3 times 3 over 1, that equals 2. So 2x. Now when we subtract 1, what happens is we're subtracting 3 over 3. Now, since the numerators are the same, we can continue. So it's 2 minus 3, which is negative 1 over 3. Now, here there are a couple of things that we have to do. It's best to not write the x having a fraction or a negative. So here we have to fix both of those. So the 2 remains the same. Since it's negative, we bring the x downwards into the denominator. And so it's raised to the first power and the cube root. So this is our final answer. So f prime of x equals 2 over the cube root of x. Now, if there was a follow-up question, let's say, and it says find gradient when x equals, for example, 64. I take that 64. Yeah. So we know that the cube root of 64 is 4. So it's 2 over 64, which equals 2 over 4, which equals half. So that's our gradient when x equals 64. So that'll be it for today's video. I hope you understood, and in the next video I'll be talking about how to differentiate using first principle.